Okay, hello, I'm Adriaan. I'm a Senior Devops Consultant at Eficode, and I will be giving you an introduction about GitHub Copilot and some demonstration on how you can become a better software developer using GitHub Copilot. First, a bit about Eficode. We're 600 professionals strong in 10 countries, mostly in the Nordics and in Western Europe, but also now a bit in the US and Central Europe. We help our customers write better software using tools like Azure in the cloud or like integrated tool chains like GitHub. So what is GitHub Copilot? You might have gotten already a bit from the previous talk. GitHub Copilot is an AI pair programming tool. It builds prompts for you based on the context it gets from your IDE. It passes those over to the Open API AI codex, and then you get suggestions straight into your IDE. So it really is a power tool to make you use those LLMs more effectively without having to go back and forward with the, for example, a chat interface in between. It's consumed as a software as a service product. So you buy a license either as an individual or as a business, and then you get an IDE plugin, which does this integration for you. And most well-used like IDEs are available out of the box. So when you start using GitHub Copilot, you have various techniques to start using it. The most obvious one is using it as like autocomplete on steroids. Most IDEs already have autocomplete in there, but it can only source as much as it knows from your code. For example, it can suggest existing variable names or other methods it knows which are available, but it cannot help you with writing business logic. So here you will see that Copilot, the AI behind it, actually infers how you should implement your business logic, for example, based on the names of your methods, and then you don't have to do it yourself. So here you see that you have more productivity because you just get these full suggestions automatically for you. A second way is to kind of create more context for this AI. Sometimes you just don't know what you want to write next. So what you can then start doing is you just write out the method name or you write out a comment of what you're trying to achieve. And then you let the Copilot AI pick up on that and actually do the implementation for you. Now you have this advantage that you both have the comments of what you're trying to implement and the implementation living together. So you get well-documented code out of the box, and it's even faster than writing it all by yourself. Thirdly, if you want to start building tests with Copilot, it can help you write test cases for new unseen edge cases you wouldn't have come up with yourself. So this AI has some originality in it, or can kind of know like default test cases, and will suggest you to kind of prompt additional test cases to pull into your test suite. This allows you to build more test coverage faster, which in the end makes it easier for you to validate that the code you're writing is actually working. Lastly, like one very powerful tool is that you can use it to evaluate different ways to go about an implementation. Often when you already know like how you want to go about a certain implementation, you will just have only that one vision in your mind, like where you want to go. But what you can do is instead you can kind of remove the code you've been writing, and instead you prompt it to give you 10 different suggestions for what you actually, how to continue from that point. And then you can see these alternative implementations, which gives you more insight in like how others would have solved the same problem or what kind of different ways you can go about it. And this can be things like coding style, like let's say like you're comparing functional programming versus a more imperative style, or it can be things that it's like it uses different like algorithm under the hood or a different library altogether. So you get more understanding of the context you're working on. This is a way you can both also learn and find the more optimal solutions for your implementation. So to get access to GitHub Copilot, it's nearly a plug-and-play experience. What you do is you need to get a GitHub Copilot license, which is attached to your GitHub account. Then you install the GitHub Copilot add-on into your IDE. For example, for Visual Studio Code, you just get it from the marketplace, and then you authenticate and you're ready to go. You will immediately see the suggestions flowing into your IDE. One note though, if you want to use this on like corporate data, the data will be sent to the cloud, and you don't really have control over the prompt it will build. So if you do it with sensitive, like personally identifiable information or secrets, you might want to check whether this is compliant with your corporate policy. So now for a short demo.
Okay, let's get into the GitHub Copilot demo. For this demo, I prepared a small Node.js repository. There is no business logic yet in this repository. The only thing there is just a lot of configuration for different kinds of tooling. Most notably, we have a unit testing framework just installed, and it's continuously watching the repository for new tests to appear. So soon, once we get actually working on those tests, you will see them pop up. Besides that, in VS Code, I have installed the GitHub Copilot plugin. It's authenticated, otherwise you will see this notification on the bottom left. And then here on the bottom right, you see the GitHub Copilot icon. If it has this gray background, it means it's activated and it's ready to be used. So what are we gonna be making this demo? I want you to learn GitHub Copilot by writing a small utility function which sums all even numbers and divides it by pi. Just spinning it up a bit, because normally all these kind of examples are kind of trivial. But here, like just dividing by pi, you will see that it won't like it that much, because pi is also a weird number for it to divide, and actually floating point arithmetics by the AI is not that good. So you get kind of these like corner cases where it's not just able to get this from memory or from like, it's not like overfitted on just a specific problem, but we get something unique. Besides that, when I write the business logic, we also want to write some tests. Function, cool. So how I'm going to go about this, I'm first going to show you how to write business logic, then write tests, and then I'm going to go back to the existing source code and show like how refactoring, now that we have the test in place, is actually very easy. You could also start with writing tests. The nice thing I think about starting with the source code is that it can show you like how Copilot also helps you define the API service, or at least gives you suggestions, and it's not just inferring that from the tests. So now that we have this kind of completely blank slate, Copilot doesn't really know what we're trying to achieve. It might have understood a bit from the README, but in this case, it's still going to be quite blank. So now if I'm going to prompt it towards writing a new function, so let's say call it get sum of even numbers, that would already kind of give it some information, but still this doesn't include a requirement that it also needs to divide it by pi. So if we would go down this path, you see that it doesn't actually understand it needs to divide by pi, but and divide by pi. So if we add that, and we would now remove this line, you can see that it kind of understands that it needs to adjust the way it implements this method. If you keep making changes, then it will not automatically fix it, but you can kind of keep doing this trick. So let's say like we want to have the square root of pi. We'll remove this again. You can see that this works. We can also just remove the entire implementation, because at this point it does pretty much all the context of what we're trying to achieve inside in the context which is already available. So it can from there on regenerate the code we need. The more like the kind of removing specific parts is easier if you know where you need to make changes and you just want to isolate them. By removing everything, there is this risk that it will go with a completely different implementation. Because it loses this context on what you had before. Another trick is you can open the side panel, and then it will start generating multiple solutions. So if you're not sure like how to go about it, or you don't like the first solution you see, you can kind of wait until it just comes up with new ones for you. Let's get back to the divide by pi to keep it at least a tiny bit simple to reason about what's happening. So good. Our implementation. For example, like I can also show like if you want to guide it towards a specific implementation. Let's say I prefer for loops and like having a counter. So it's like const like sum is or let sum is 0. So this means that we have a mutable variable in JavaScript, and then you see that it knows okay, it's mutable. It's in all likeliness we're going to iterate over all the numbers in this array, and we're going to like add them to this sum. Closing brackets, yes. So different way to implement the same logic. Now the last thing we need to do, module exports. This is just to make it available such that we can import this method somewhere else. Specifically, we want to have it available in our tests, which we're going to get to now. So for a test, we first need to import it, fix it up. Oh. Yes, write our first test. Can also like at this. Wow, good, nice. So it already came up with like 3 different test cases. You can see here is floating point arithmetic. Probably not exactly right, but we can help it later with this. Save this, fails, well, I'm missing a bracket, yes. Good, so 2 passed, so these first two they're gonna pass, but this one doesn't. Yeah, it doesn't figure out this the actual like multiplication or division by pi here. What we can do though is if we just like tally these up ourselves, so 12 over math of pi, and you'll actually see that it will be able to expand these, like to do this arithmetic there. So it will generalize to that kind of level of intelligence, but it doesn't fully understand like floating point arithmetic. Let's see if we can show that. So let's add like another number, 10. So here you see that kind of, like it understands, like it can do this like basic things like addition or like summing values, but not all the way. Also what would happen if, yeah, like 7, 14. That's kind of region. So here kind of see that we kind of tricked it into giving us the wrong result. So, but so it's not perfect at these kind of things. Like it doesn't entirely understand it, but it can generalize these like standard patterns. So the same as we had with like when opening the panel, like you can get more suggestions. So you can still do that. I'm sure if it's going to get much more interesting here, but it seems to stay a bit within the same realm. I'd like to have one where it would just pick odd numbers. Oh no, we already have one with only odd numbers. Yes. So, or it would mix them. Let's go with one where it mix them. Then we have a bit of confidence that we can both deal with empty array. Here, this one. Some solution. Cool. Okay. So there we have another test. This is basically just combining this and this array for the last one. Well, I'm not particularly fond of this kind of notation where everything is in the same, is in one line. It's kind of hard to read here, like what we're actually trying to test. But so one way how we can refactor this is if we just comment this out, and now we kind of start writing a test like in a different notation which we want. So let's say we want to have this explicit arrange, act, assert kind of format, and then you'll see that it will kind of pick up on like how we want it to look like. And you can kind of just do this everywhere. The nice thing is that over time, like after like there's enough context around like how you actually want it, then it will just keep suggesting like this new standard. So if we would have prompted for new tests, it would like give it again in the new kind of format. So, arrange, still too much context for it. Okay. Cool. And then last one. So let's comment it out. That at least keeps it. We can also like ask it for like the full synthesization of yes once and just get everything. Cool. So there we've refactored like our testing style. And like I said earlier, like if we would ask it now for new tests, would see that it would kind of stay within this kind of new style we picked up on. So this is very nice that it kind of it doesn't pick like it will converge towards your coding style after that's seen some examples of how it should look like, which means your code base is going to be more consistent in styling. So now last to wrap it up, so like not just this kind of refactoring, but also this kind of refactor for the implementation. I've already seen it knows like how to get like different implementations, so you can just delete it, ask it for like new ones, and just accept it. And now that because we have these tests, like we kind of know that we have confidence in that we can make these refactors safely. So this like going back and forth between writing business logic and writing tests is something which becomes very easy. And it's in this way, it's like just a lot easier to do test-driven design because writing all these boilerplate code, you just get it for free, and it just makes it a lot less tedious for you to kind of write your tests and get like proper test coverage. And ideally, even it gives you kind of some suggestions on edge cases you wouldn't think about yourself. But that will emerge more in more complex examples actually than in this one. You get a couple like this empty array. And some might also not apply. Like you might see that it will, for example, try to like pass null into the test, and the function or test will not support that. So it might not really make sense if this one is not designed to write these to support null as an input. Lastly, we can also like ask it to write documentation. So let's see, get out here. So like from the implementation, it will kind of start to prompt entire like JS docs and suggestions on how it should look like, including even like examples on how it should work. But yeah, it's always kind of important to kind of still kind of read what's happening here, because often it's right, but it's still especially if you have like many suggestions, then it's like lower and lower confidence on whether it is right. And here it could like forget things like this divide by pi. It might not like always recall correctly. Cool. So I think time is up. This should have given you like a bit of an overview on like what you can do it, like how fast you can. This allows you to kind of write code, but also kind of the sharp edges that you do still need to be vigilant about, like how you use this tool, and that you still need to understand like how to convert your own business logic into code, because it's a copilot. Like it's there to kind of like help you make better code, but you're still the driver and need to make the decisions, which code to pull in and which direction to go. And once you get like comfortable with steering it into the direction you want, and or if you like have a feel of where the code, like how the solution should look like, it makes it a lot easier for you to just get your work done and move on to like the next topic.
For this demo. So in summary, with GitHub Copilot, you have a coding assistant to help you write better code. It uses the OpenAI Codex technology under the hood, and it's just a straight integration into the IDE. It's basically like a power user tool for you to kind of more easily interact with these LLMs. It helps you to be more productive by completing code, write better code by suggesting tests, and it enables learning by giving you different implementations to use. Thank you. These are my contacts. Please reach out. Otherwise, see you later.